Well, the effect of pH in the amount of molecular SO2, that is the really effective to control microbial developments in the wine processing, but also to favor the physicochemical stability, is affected strongly by the pH. So with the same amount of free sulfur dioxide that many times we said that is suitable dose, 30 milligrams per liter of free sulfur dioxide. If the pH is 3.5, the level of sulfur dioxide is around 0.8 milligram per liter of molecular sulfur dioxide. It means that the wine is protected, perfectly protected against Brettanomyces. However, the same amount of sulfur dioxide at pH 3.7, that is quite normal in many wines, produce levels of 0.5 milligram per liter or lower that start to be risky concerning the formation, the development of Brettanomyces. Also, the pH affects a lot the antioxidant activity of sulfur dioxide. You know that in healthy grape, we have oxidative PPO enzymes like tyrosinase. So we need at least 50 milligrams per liter to control these oxidations. But this works really good at pH 3.5 or lower because the effectivity or the activity of these enzymes is lower than 20%. However, if the pH is close to 4, the activity could be really much higher, even at this level of 50 milligram per liter. The situation is much more extreme when we are working with botrytis-affected grape, and we need amounts of near quite close to 100 milligrams per liter. Even with 100 milligrams per liter, if the pH is higher than 3.5, the situation is quite uncontrolled. So the pH is affecting strongly the effectivity of sulfur dioxide against microorganisms and to control oxidative processes. Well, concerning the physical techniques, we can use currently very effective cation exchangers. Cation exchangers are polymeric materials, many times polyestyrene sulfonate or other polymeric materials that have sulfonic groups that becomes really strong cation exchangers that can retain protons at very high level. So when we pass across these resins, these cation exchangers over wine, the wine release potassium and calcium and magnesium and other cations, increasing the amount of protons. So we get better acidity. The technique is really efficient. We have many companies that are producing these resins inside cartridge in which we can automatically process the wine, and the wine with high pH pass across the resins, releasing cations and increasing the amount of protons, producing a very acidic wine. It's really effective. It's really easy to put more than, to decrease the pH even lower than 3. The only problem is normally these treatments are quite aggressive and are affecting not only the pH, also the aromatic compounds and the tannin and color structure. Now, the OIV is allowing these techniques and we can increase the acidity until 54 milliequivalents per liter, what means more or less one global acidification at a maximum of the equivalent in tartaric acid of 4 grains per liter. So it's quite effective and quite strong. However, we should reach pH levels higher than 3, and many winemakers use this technology not at the level of the full wine. They apply the cation exchanger just to a small fraction to at the end blend the processed, the treated fraction with the initial wine to affect less the sensory quality. The main problem is that